Hi, fourth graders. Today we are going to learn and talk more about electricity and how energy flows through the electric currents. So yesterday you were able to explore with your circuits and build a new way to get electricity to flow through a power source and turn something on. Hopefully you were able to have fun with that simulation and experiment. So this is just a quick review of what that circuit looks like. You always need a power source, and that is what provides the steady flow of electrons. An electron is that tiny piece of electricity that's moving. The electric circuit is then the pathway that the electrons can go, and it goes and makes a circle looping from the power source through the light or whatever you want to turn on and back into the power source. So you can think and brainstorm about all the places in your house that use electricity. Today, you are going to create and fill out your own alpha boxes form as you read in our textbook about electricity and watch a quick video. I want you to do your best to spread out the words in as many boxes as possible. Some of those boxes may have more than one word, and that's okay. And some boxes like Z may not have any words. So you will do this when it's time for you to add a response to Seesaw. You can fill in. You can see I have the word circuits for letter C and electricity. So now we are going to read, and I'm going to let you read this page about the electric current. This will be in your add a response for you to read and fill out your alpha box. So you can come back to that part. And we're just going to watch the first 10 minutes of this Bill Nye video about electricity. I want you to fill out your alpha boxes and take some notes as you're watching so you can add in some words that you hear. Let's check it out.
The same thing that makes this happen makes this happen. And this. It's electricity. Whoa.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Bill.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy. Brought to you by Electrons, making your world a brighter place.
Hey, is your TV on? If it is, that's great. You're using electricity. But if you're watching the show and your TV's not on... Anyway, what is electricity? I mean, where does it come from? Is it just sitting in the wall waiting for us to use it? Or is it constantly spilling out of sockets and we don't notice it? And how can something so powerful be invisible? Well, electricity is the flow of tiny particles called electrons. And they're not just smaller than atoms, they're actually part of atoms. Take a look at this. It's our battery-powered electrical circuit of science. We're going to run this big light with this big battery. Watch.
Attention, Nile Lab
See,
shoppers.
right now, electrons can flow from this side of the battery, through this wire, through the switch, through this wire, into the light, and back to this side of the battery. They're flowing in a closed path, what scientists call an electrical circuit. Now, circuit, that's from an old word for go around. So electrons, right now, can go around an electrical circuit. The flow of electrons is a lot like the flow of water. No kidding. Watch. When I operate this great big water pump of science, water goes through this hose into this box and makes this water wheel go around. And it goes out the other side and through this hose back to the pump. It's a closed path for the flow of water. It's a water circuit. It's just like the flow of electrons through an electrical circuit. Electricity is a very versatile form of energy. The same electrons that are making the light light up are making a motor go around. See, Electricity can do all kinds of different jobs, and they're all done with electrons.
Electrons flowing through a wire are a lot like water flowing through a hose. When we got the flow going, we can do work.
Bumper cars have electric motors. The electricity runs from the rod that touches the ceiling, through the electric motor in the car, and then to the floor. So you don't get a shock from the floor unless you can touch the ceiling at the same time. Otherwise, it's not a complete circuit. Sirens!
Keeping batteries in the refrigerator makes them last longer. Your brain uses the same power as a 10-watt light bulb. Cold metal conducts electricity better than hot metal.
Now you know! There's enough electricity coming out of the wall to stop your heart. So don't stick anything but a plug in a socket. Be careful. This is Godzilla's hairdryer, I think.
Check this out. It's an electric train. It has 2 rails. Electricity goes in one side, through the motor in the engine, then back out the other side. It's a circuit.
So where does electricity come from, anyway? Well, in 1831, 2 scientists figured out how to make electricity. It was Michael Faraday, working in Britain, and Joseph Henry, working in the United States. At about the same time, they both did an experiment, something like this. Michael Faraday took a coil of wire, and he moved it over a magnet. And when he did, electricity started to flow in this coil. The electricity went down over here to another coil and made a compass needle move. Well, Michael Faraday was doing this experiment for an audience, and a woman came up to him afterwards and said, Mr. Faraday, of what use is it? And he said, Madam, will you tell me the use of a newborn child? And what he meant was, would you take a look? I mean, I'm moving the compass needle without touching it. You understand? I have a coil of wire way over here, and I'm making a compass needle move way over there with no apparent force. I mean, some force is going right through the air and wiggling that needle. Something's happening here. Some spectacular effect is happening here. You may not completely understand it right now with no apparent force. One day we will, and it's going to be a big deal. Thank you for joining me on... Consider the following.
Iyer, and I'm a scientist working on electric cars at Western Washington University's Vehicle Research Institute. And this is an example of what we have. This is Viking 21, an electric hybrid car. Viking 21 is the forerunner of electric cars, the way steam engines were to gasoline cars, say. This car is a solar electric hybrid, which means it runs on solar power, electricity, and also on compressed natural gas. There are 1,400 solar cells on this car. Solar cells convert light into electricity, and this is stored in the batteries. And this electricity is used to drive the electric motor in the front and electric motor in the back. The batteries actually are all charged up. So if you guys want to go for a spin, let's roll, let's burn rubber.
Electricity is the flow of electrons. Electrons are the tiny particles that buzz around the outside of atoms. Now, when electrons are able to jump from one atom to another, well, that's the flow of electricity. Now, in some materials, like metals, electrons can jump from atom to atom very easily. Atoms in metals are like a bunch of beehives. The electrons are like the bees buzzing around the hives. When electricity flows, it's like the bees jumping from hive to hive. That's electricity.
You can make an electrical circuit and figure out what things let electrons go through them and what things don't. Hook up a circuit like this. The tricky part of a circuit like this is getting the batteries to stay put. We've got it all worked out. Test things and see if electricity goes through them and what things don't. It seems that metal things carry electricity pretty well, and rubber and plastic things don't. Try this, a pencil. Now a pencil slit in half. Check it out, it changes. The circuit's complete, but the pencil lead is holding some electricity back. Things that let electricity go through them are called conductors. Things that don't are called insulators. This can be called a resistor. It's somewhere in between a conductor and an insulator. It lets some electrons go through, but not all. Wild! Wild! Wild!
Uh-huh.
So fourth graders, now it's your job to go add a response. And first you will read about the electric current from our science textbook. Remember, your job is to fill out your alpha boxes and find words that talk about electricity and circuits and fill those in. Don't forget to submit when you are all finished.